In this video today, we're going to try to compare Crossplane version 2 with a combination of KRO, Kubernetes Resource Orchestrator, and ACK or ASO or GCC. Trying to compare those tools is pretty interesting, and there are both options to bring up infrastructure as code using Kubernetes API server as a main point. And that's what we're going to do in the next few minutes. Have a look, let me know what you think, and ask questions. 2025, and when I submitted this talk, I thought I'm comparing Crossplane, the left-hand side of the car, a very ancient thing, with something very cool and modern. That's the right-hand side, a brand new car, which I thought was going to be KRO and ACK or KRO and ASO, but well, turns out I was a little bit wrong. It turns out that at the end, the difference between these things is a little bit more like, do you like more sweet or do you like salted in the morning? What's the type of breakfast that you're using? And if you drill that down into, these are both tools that we kind of use for bringing up applications or infrastructure as code, then you can compare them with red or gray bricks. And if that sounds boring, well, it is indeed not that boring, and they are not that simple. There's a lot of things to learn. So if you're new to Crossplane, if you're new to KRO and ACK, and if you want to hear what the difference are and how you kind of can take a decision, then this is a good video for you to watch. So we're going to take a closer look at how that actually works, and we are going to understand or try to see how the tools are operating. And I think that's going to help you a lot. So we are focused on infrastructure as code, comparing Crossplane V2 with KRO and ACK. I'm going to call out two people that have helped me to prepare this talk. On the one side, Christopher. He's a Crossplane contributor and helped me a lot to understand and to bring up this talk. On the other side, Jack Muller. He is a maintainer for KRO, the Kubernetes Resource Orchestrator. And with that, a very important source as well for the different parts of this agenda. What are we going to look at? We're going to look at terms and definitions. We're going to then look a little bit around stories and hear a little bit how the different projects got created and are founded. And then we're going to see where Crossplane and KRO are similar, before we then move over to see where Crossplane and KRO are different. And then we're going to look at the decision tree. So all of the tools that I've mentioned so far built on the assumption that the Kubernetes API is the central place of everything in the platform or in the software that you are building. Kubernetes API server, having a database called etcd, will centrally store and connect all of the different parts of all of your applications and and tools that you're running on a platform. So let's look at what we want to achieve. At the end, what we want to achieve is that we want to have users that can request a database in a very simple way. And if you know AWS a little bit, right, you know that to get a database, might it be an RDS instance or anything else, you need more than just that. It's not just create a database, right? It requires you to have an VPC where the database can be executed. It requires you to have a subnet. You need an RDS subnet. You need an IAM role. You need a security group. And you need, at the end, the database server that is being created before you can actually then create a schema or create a database table or anything in that. And then if you're building your platform or your application on Kubernetes, you potentially also need a Kubernetes service role that allows you to connect to that RDS instance. So a lot of things that the normal application developer, which is the user in our example, right, doesn't really want to deal with. This user really just wants to interact with the database. He wants to create that database and then from there start getting and working with the database. And that's where the concept of platform engineering comes in, right? Some cool user, some person knows all of the details, how to combine the RDS instance and create the RDS instance. This can be either with CloudFormation Terraform, or it can be with ACK, or it can be with Crossplane. But he knows how to do that and how to do the different combinations. That is a person that we nowadays call a platform engineer, right? He defines that component of a platform which can then be consumed. Platform engineer defines how this database thing is structured. And both Crossplane V2 and KRO and ACK, or KRO and ASO, the combination of those allow us to define this boundary, right? So to make it simpler for the users to use that portion of it. And that's the main benefit of the tools that we're going to look at today. Other terms and definitions that we want to cover, and I think we already mentioned that, infrastructure as code, EAC, right? That's the idea of using code to define infrastructure that you need. It has become very modern with the cloud applications. Every hyperscaler has its own flavor. For AWS, it's called CloudFormation. That you have Terraform, you have Pulumi, you have Crossplane and KRO and ACK, and we're going to look at how these work today. You then have the difference between infrastructure, like infrastructure needs to be instantiated from the cloud provider, and you have Kubernetes objects. From a Kubernetes perspective, you have the different types here that we want to define as a controller, right? A controller is attached to the Kubernetes API server. It reacts on resources that are being added to the API server. It runs a control loop and a reconciliation loop regularly that makes sure that the desired state is achieved. You can then extend the Kubernetes API server with custom resources where you can teach the API server specific combinations of custom existing resources or of things that should be happening, right? And you can then also build your custom controllers or so-called operators that then react on your custom resources. And both Crossplane V2 and KRO and ACK, they all use that methodology to achieve what they want to do. Right, in different flavors, and we're going to look at that. Right, the API server is ensuring that reconciliation loop happens regularly, and that makes it simple at the end, right, to get to this desired state. Platform engineering we already covered, the idea of reusable constructs, and essentially the excellence in building reusable infrastructure constructs, right, within an organization. This can be all type of things, right? But that whole platform engineering thing is more a methodology than it is something specific. But a lot of people have been trying to define that in various different flavors in the past 3 to 4 years. There's been a little bit of a hype around that as well. Then last but not least, Common Expression Language. This is used is an open source project created by Google. It extends YAML by some functionalities, and KRO makes use of that. So I wanted to cover that as well. So let's look at how that all works, right? So how are things kind of working together? So the user on the left-hand side tries to wants to create a database, or in our case, tries to create an application. That user defines this YAML file. The YAML file has specific information and applies this YAML file using kubectl or something else to the API server. You can also use GitOps, Argo CD, Flux, or whatever you want to use to apply that YAML file to the API server. What will now happen is the controllers that we have, and we have 2 examples over here, they now watch this API server and the changes with the definition of this custom resource being added over here. These controllers now know what to do, right? They react on that change of the Kubernetes API server. These controllers then look at what they need to do and how to reach the desired state. And both Crossplane and also ACK and KRO do the same thing, right? ACK is in this example responsible for controlling the AWS infrastructure that sits outside Kubernetes. But you can also have a controller, obviously, that manages Kubernetes objects, right? But the idea really being we are extending the functionality of the Kubernetes API server to also be able to control cloud infrastructure. And that's what we kind of do with the different controllers, and both Crossplane and ACK and ASO and GCC, they all have the same functionality and possibilities that you can actually do, right? Pretty important because it really extends Kubernetes, right? It gives you the possibility to control everything that your application needs from the Kubernetes API server. And this means that you're able to define connections between the cloud infrastructure and the applications running on Kubernetes, which you usually needed to do as a separate step of your deployment process. So a pretty powerful thing that we're trying to achieve and trying to do here. Okay, the history and stories section we're going to cover only very briefly, right? Especially for defining the different tools. Let's start with the most ancient tool. Crossplane was already created in 2018, and Crossplane was initially focused on extending the Kubernetes API with provisioning of infrastructure capabilities. That means it tried to extend the Kubernetes API to provision infrastructure, but then later on, Crossplane became much more. It made it possible to provision Kubernetes infrastructure as well. It then used Terraform providers under the hood to create infrastructure initially, right? And then that developed a little bit. Now we have the object provider system. But as you can see, Crossplane has been around for a while. The three mentioned operator projects that we have over here, ASO, the Azure Service Operator, ACK, the AWS Controllers for Kubernetes, and GCC, the GCP config connector, they are all operators owned by the three hyperscalers that we have over here. They have been added in different flavors, right? But they all do the same thing. They extend the Kubernetes API to be able to provide provision infrastructure that is on the relevant hyperscaler, and there is more than just those, right? But they kind of came across very long, and as you can see, ACK is the newest one from AWS, and ACK has been taking it very slow at the beginning, so they haven't been supporting a lot of the AWS resources until mid 2025. That has changed a little bit now, right? But still, it was very, very slow. But the most important thing here in this timeline, I think, was the announcement of KRO in 2024, I believe, right? When AWS, Google, and GCP together announced this project as being an open source, and especially them working together on this open source project. So there's dedicated resources from all of the major cloud providers working on KRO, and I think that's pretty powerful, right? If you see that these hyperscalers who usually don't work together in this project come together to provide a composition engine and extend the Kubernetes API server with a composition engine, right? And that's essentially what KRO does, right? We're going to look at a little bit more into that in a few minutes. But this announcement of KRO forced Crossplane to announce Crossplane V2, which simplifies Crossplane a little bit and brings some of the features that have been requested for a while in the community, right? But also you can see that there's some, let's say, nuances of collaboration that are missing within the ecosystem, because KRO and Crossplane, they kind of do the same thing. They are kind of both composition engines. Crossplane nowadays is way more than that. We will talk about that, right? But in general, you can say, oh, it would have been cooler if these two groups would be working together to solve the end user needs. And maybe that's what we're going to see in the future. But let's not look at the future now. We can look at that a little bit later. And with that, we are kind of done with the initial part of the section. We are now going to look into details. And I am eager to see how you like that. So how does Crossplane work? Crossplane has custom resource definitions. Crossplane V2 has custom resource definitions that are namespace. Those are the definitions that you write on your own. Crossplane also has compositions, which are at the end combinations of custom resources. You also can put them namespaced in V2. That was not possible in V1. In V1, Crossplane was only operating on a by-cluster basis. You then have providers. Providers are custom written operators, sometimes also generated operators, and the ecosystem for providers is really, really big. So there's a lot of people contributing and creating Crossplane providers. You can do kind of whatever you want with the Crossplane providers. The main thing here really is then you can extend Crossplane with these, and this gives you the possibility to control your WAF, to control IAM permissions and stuff like that, right? Because that's all just available within that ecosystem. You also get something like provider Kubernetes that you can use to instantiate Kubernetes resources. But as of V2, you can also directly interact with Kubernetes resources from Crossplane. However, it has the problem that you will need to implement some of the provider-specific information within your CRD, right? That means you need to actually check if the Kubernetes resource was provisioned correctly, yes or no. And I would wish that the Crossplane team would make that part a little bit simpler in the future. Crossplane continuously reconciles the desired state. So it follows the Kubernetes idea of being able to reach a target state. And what does that mean? If you have the RDS database that we looked at a little bit earlier, the RDS database has some dependencies. Crossplane will try to create all of the infrastructure components at the same time, which essentially means it will try to create the security group without having the VPC information, which will then cause a failed API call. So it will constantly try to reconcile that, and that creates some problems because a lot of API calls will have missing information in it, and with that, the infrastructure will not be created. but you can still fire a lot of information, a lot of API calls. So for us, this meant when we created multiple VPC endpoints using Crossplane, we hit the EC2 limits, because the EC2 API limits, because Crossplane was constantly hitting the APIs with wrong parameters. And that forced the EC2 API to throttle our API requests. So I think that's something you need to just know about that. Crossplane being that old also means that there's a lot of community projects around Crossplane already. That means things like Comoplane that you can use for visualization, also the Upbound SaaS product that you can use to visualize and to interact with different control planes. I think that ecosystem is pretty strong, but that ecosystem also means that it's dominated by certain players, and that means that sometimes I would say some things are being merged that are given a little bit better place than others, right? Just because it comes from specific people, and I think that's something that also you need to know. Crossplane itself is an ecosystem, right? You're being tied into that, and it's really hard to get out of that if you want to later. You could potentially extend Crossplane with ACK, ASO, and GCC as well. So you could use Crossplane only for the Kubernetes portion of it, and then use the operators of the cloud providers to create the infrastructure. But it doesn't really make sense, right? In addition to that, Crossplane has the possibility to write your custom resources in multiple languages, and we're going to look at that a little bit later. How does KRO work? KRO works essentially in the same way. There's one difference, right? You have no compositions, you have resource graphs, and you can define these resource graphs. This means that when you use cell to define your YAML files and your infrastructure as code in your CRD, you're also defining dependencies as part of that. With those dependencies, you then actually get the possibility, the KRO analyzes those dependencies and builds up an internal resource graph. That internal resource graph is a dependency graph. That means the RDS database will not be created until all of the prerequisites that we need for that have been fulfilled. And that's pretty important, right? Because it doesn't bombard the cloud provider's API with a lot of wrong API calls, but it still tries to reconcile. But it follows an order that you have defined. You can achieve the same in Crossplane using pipelines in the custom resource definition, but then obviously you lose a lot of benefits from a Crossplane perspective as well. So KRO builds that dependency graph out of the box, and that's pretty powerful. Visualizations of resources for KRO need to follow the normal CRD resources, so K3S or whatever you want, K9S, K3S, whatever you want to use to visualize your CRDs, you can use that as well. And then you can create infrastructure, again, using ACK, ASO, or GCC, or you can even use Crossplane providers to create infrastructure, because KRO only manages the standard Kubernetes objects, right? And it constantly reconciles those CRDs. So where is the difference between KRO and ACK then? I've just been highlighting a lot of the things that are the same. Both use so let's look at that first. Both of them use the Kubernetes API server as a single point of truth. They both extend the Kubernetes API with custom resource definitions and make it more powerful. And they both use tool-specific operators to translate CRDs into infrastructure. Right? I think that's pretty simple. If you then look at where they are different, right? The Crossplane ecosystem is very, very strong, but very, very locked down, right? So there's no Helm charts for Crossplane operators and resources. You have Crossplane packages. You need to be in the Crossplane ecosystem to run the providers. That's a little bit hard, right? KRO is very puristic and very native to the Kubernetes API, which is pretty cool, right? As we already talked about, the eventual consistency of Crossplane versus the direct acyclic graph, the graph that KRO creates, we already know that difference. I think that's important to know. Crossplane V2 also allows something that we call operations functions, which then at the end gives you the possibility to run functions on demand and scale a database or scale something on demand, right? So where Crossplane is able to modify some of the resources if required. Right, Crossplane V2 also allows you to define all of your resources using Python, TypeScript, Go, or some other languages as well, or KCL, right? And this gives you more flexibility than just the cell expression language that KRO supports, right? So I think that's the main difference as well. If you're more coming from a developer perspective, you might feel better writing Crossplane than you might want to write YAML. You never know, right? But that's where Crossplane is very strong. It has a big ecosystem of what you actually want to can achieve over there and can do. So let's go to the last part of the section, and let's look at when to use which of the tools and maybe also why. And if you have a different opinion than me, please let me know in the comments and let's talk about that. So that brings us to the last part of this video, where we are going to look at when to use what and why. And please be aware, this is my own take on this, right? So my own opinion. Others might have other opinions. And if you have other opinions, please let me know in the comments. I'm eager to hear those. So for me, my advice would be to use Crossplane V2 if you're building a brand new project where you are okay to be locked into the Crossplane ecosystem, and where you are okay to be locked down into all of the provider stuff that is being done. Right. Also, if you need some flexibility, if you need a lot of variety of different resources in the cloud, then Crossplane definitely has the most expansion points already available. So I think that's where the Crossplane ecosystem would help you a lot, right? But obviously be aware you're then locked down into that, right? So if you want to write more than just YAML, you should also go with Crossplane V2, because there you can write Go, TypeScript, Python, KCL, right? And you're not bound to Cell, which is the language that is used for KRO. I think that's my advice over here. If you're just building a smaller project with minimal AWS resources or infrastructure resources required, then KRO and ACK, ASO, and GCC are, I think, a good way to go, right? Especially because I can see the hyperscalers supporting KRO in the future and investing into that ecosystem as well, right? So I think they will be working together to ensure that this project really flies, because it makes them not dependent on Upbound. And I can see maybe the potential of the composition engine in KRO becoming part of the API server in the future. So if you're already a Crossplane V1 user, I think it's a very hard decision. It's a very tough one, right? Because migration from V1 to V2 is actually nearly a rewrite to be able to use the new functionalities that Crossplane V2 has. As of now, custom resources from V1 are still going to be supported, but next year Crossplane will deprecate the availability of the current structure, and then you need to be migrated, right? And I think that's going to be a problem, right? So you might want to really think about, is it worth migrating to Crossplane V2? Am I happy in the ecosystem, or do I want to just move over to the other options where I have a more enterprise supported approach, right, than Crossplane? I think that's a tough decision that every organization will need to take. And with that, let's try to look ahead. So what I wish for, right? So I think I'm hoping for some consolidation. I was very disappointed seeing that Crossplane V2 and KRO are kind of doing the same thing, which essentially is a composition engine for Kubernetes, right? And I think the adoption of these tools will decide on which one of the tools will still exist in 3 years from now, just in the same way that NGINX was just deprecated for the Kubernetes APIs for Kubernetes, and now you all need to move to the gateway, right? I think that's a good example for what will happen in the future, right? And I think that's what I'm wishing for, right? And I hope that there's going to be a little bit more integration into the ecosystem with the different tools. So I don't know what you think. I'm curious to hear. Please tell me what you think, when to use Crossplane V2, when to use KRO. Put that into the comments, and then let's start having a conversation around that. Thank you so much for watching. I hope that you enjoyed this video. If you didn't, please let me know. If you did, yeah, drop me a comment so I know what you liked and what I can do better. And looking forward to see you on my channel pretty soon.